So till now we having seen the shear connection. Shear connection based on the welding, shear connection based on the bolting, right? Now we are going to see the eccentric loaded connection. Eccentric loaded eccentric loaded connection. So in the eccentric loaded connection, this also based on the design is based on bolt or rivet, and design is based on welding. Okay, the design is based on design is by means of bolt or rivet. Next one is design is by means of welding. Okay, further this design is classified into two, that is case A. Case A, in plane loading, in plane loading, and the next one is case B, that is out plane loading. In plane loading and out plane loading. Similarly, for this one, case A and case B. Case B. Case A, in plane loading, and case B, out plane loading. Out plane loading. Okay, so in the eccentric loaded connection, there are two, by means of bolt, by means of welding. In that, by means of bolt, in plane loading, out plane loading. By means of welding also, in plane loading, out plane loading. Okay, first of all, what is eccentric loaded connection? So the definition of eccentric loaded connection is this one. If the center of gravity of bolt group or weld, okay, bolt group or weld does not lie on the does not lie on the line of action, does not lie on line of action of load, does not lie on the line of action of load, then it is called then it is called eccentric connection. Then it is called eccentric connection. See, if the CG of bolt group, center of gravity of bolt group, does not lie on the line of action of the load, then we can call it as an eccentric connection. In that eccentric connection, there are two types, in plane loading and out plane loading. Okay. Now we are going to see first case A, in plane loading. Okay. Okay. I will explain in plane loading both bolt as well as weld parallelly. Okay, both bolt and weld parallelly. Okay, case A, bolted eccentric loaded connection. Bolted eccentric loaded connection. This is welded eccentric, loaded connection. Welded, eccentric, loaded connection. Okay, this is the bolted, this is the welded. Here case A. Case A means what? In plane loading. In plane loading. This also case A, in plane loading. In plane loading. Case A, in plane loading. Now see, in that case A in plane loading, case A in plane loading, what is the meaning? Here, center of gravity of bolt group and force acting on plate on plate lies on same plane. The center of gravity of bolt group or the bolt group, we can write this is a bolt group and the force acting on plate lies on same plane. So that is the case A. Okay, here also we can write weld group and on plate force on plate lies on same plane. Lies on same plane. So the best example is this is the diagram. Let me take. There is a bolt group eccentrically. This is the cover plate. Okay, this is the cover plate. Okay, and somewhere here there was a force. The force P is acting somewhere here, P. So P passes through like that. P passes through like that. So this is 1. 2 is a bolt group. 3, 4, 5, 6. Now see, somewhere here is the centroid. So the centroid point is this one. This is the centroid point. Okay. Now, through that, there was an axis which passes through centroid. There was an axis which passes. So this axis. So from the centroid of the bolt group, we can measure this distance is R1. This is R2. Like that, so on and so forth. R3, R4, R5, R6, like that we can measure. Okay, so this is we can simply write R. I hope you understood, right? R. This also R. This also R. The center of the bolt R. So this also R. I can simply mark this R, right? Okay, R. Now, if you resolve this force about the center point, that is a centroid. Now you know while resolving this acting at a distance of eccentricity E. Now, while resolving, this force can be converted into about centroid point as direct load and moment P into E. There are two forces are acting. One is a direct force, another one is a bending moment. Okay, now here, this is the bolt group. The bolt group lies on a plane and the force also lies on the same plane. So in that cover plate only, bolt group and load both are lies on the same plane. So bolt group and force are on the plate lies on the same plane. Lies on the same plane. Now, because of this load, what will happen? This bolt group gets twisted, not bent. It gets twisted. Okay. Now, what are the resistant force which is developed? The resistant force will be developed due to these two forces. One is the direct load PD, another is a twisting moment PT. These two are developed, which is acting by a theta. So, which is acting by a theta. What I have to do, I can mark these two direct load at the center, so that I can able to mark this the resistance properly. Okay. So this P and T I can mark here about centroid. Yes. If you resolve this, then you will get a P and you will get a P into E. So these two quantity will come. Okay. Now see, now see, the resistance or the counteraction of this P developed on this bolt, that is PD, and similarly the resistance corresponding to this clockwise twisting moment, the resistance will be developed in such a way that anti-clockwise. Anti-clockwise means is perpendicular to this axis. So this is PT and this angle is theta. This angle is theta. Okay. So this is PT. Similarly, here this is the upward force PD, and resistance due to this moment is something like that. Okay, this is PT. Similarly, the resistance this is PD, and here the resistance is here the resistance is PT. Similarly, here the resistance is PD, and this is the resistance that is PT, anti-clockwise couple. Similarly, here this is the direction of PD and this is the direction of PT. Now at this point, this is your PD and in the same direction you are having a PT also. Both are coincides. Therefore, now the theta here is always measured from anti-clockwise. This is the theta. Here the theta is 180 degree. Theta. Here this is the theta. Here this is the theta. Here the theta is 360 degree. Okay. So this is the forces. Okay. Now the bolt subjected to, we can write bolt subjected to two forces. One is direct load, direct load, therefore, or we can say direct stress. Direct stress due to direct load, that is PD, which is equal to P divided by N. Okay, or next slide I will write direct stress due to direct load. Second one, the second one is that is shear stress due to, so actually this is also shear stress only, not a direct stress. Shear stress due to twisting moment, twisting. So that is PT. Okay, now we can write. Now we can write. See, each and every bolt is subjected to PD due to this direct load. Okay, and each and every bolt is subjected to PT due to this twisting moment. Okay, so first one is PD. We can write it as total force, the direct force divided by number of bolt. This is number of bolt. This is direct load. Next, we can see this is the PT, that is a tension force. Okay, so this tension force we can write P into E, that is a twisting moment. Okay, P into E divided by summation of R square into Ri. Okay, now see the resultant force. The resultant force, if you look, this is your bolt. I can draw this here. Okay, you know, better I can mark this. Okay, here I marked, but anyhow, once again, I let me mark so that you will get a clarity. So each and every bolt is subjected to PD. So this is the center point. This also is centroid. And this angle is theta. Similarly, the direct load resistor, this is the PD, and this is the 90 degree. Okay, with respect to this axis, 90 degree PT. This is theta, and here this is theta. Similarly, this is PD, and this is PT, and this is 90 degree. Sorry, theta. Similarly, this is PD, and this is PT, and this is 90 degree. Sorry, not 90 degree theta. Similarly, this is PD, and this is the PT. Okay, shear stress due to twisting moment. This is theta, and here PD comma PT both are same axis, and this theta which is equal to 360 degree. Okay, now what is the R? R means from here to here. If you want to calculate the stress at this point, then you have to measure. This is R1. This is bolt number 1. Therefore, this is R1, and this is R2. R2. This is R3. This is R4. Okay, not this is R4. Take it in the order R4. This is R5. R5. This is R6. So that is the thing. Okay. Now what is a resultant stress? PDPT, the resultant stress is at something like that. This is PR, resultant stress is resultant force. Similarly, somewhere here you are having a FR, PR, 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 PR. Everywhere is PR is there. Okay. Now the resultant force which is calculated, PR is equal to the resultant stress, PR is calculated. General formula PR, which is equal to, we know that if two concurrent forces are acting at a point, if two concurrent forces are acting at a point, then the result of two concurrent forces is calculated by using a parallelogram law. That resultant force is determined by using this equation, that is PD square plus PT square. This is the shear stress due to twisting, plus 2 PD PT cos theta. So this is the resultant force. Now see, when we get a PR maximum, a resultant stress is maximum when two conditions. When the cos theta, when theta is minimum, when theta is minimum and R is maximum. So PR is maximum when theta becomes minimum and R is maximum. If R is maximum, then the shear stress due to twisting will be more, right? Because of this R is maximum. Okay. Now next point is critical bolt. That means the condition of critical. Condition of critical bolt. Meaning out of this 6 bolt, which one fails fastly? So that is this bolt having minimum theta and maximum R. But in the second case, R2 bolt, you are having R2 is equal to R1, but the theta is more than this theta. That's why as compared to this bolt number 1, bolt number 2 is subjected to less resultant. Similarly, bolt number 3 is subjected to less. Since here R is less, theta is more. Here theta is more, R is okay. Here R is okay, theta is very high. Therefore, while increasing the theta, automatically the resultant stress goes on reduces. Here also the theta is 360 degree and R is minimum. So out of this 6 bolt, which one fails first? That is bolt number 1 fails first. So bolt number 1 is the critical bolt. Bolt number 1 is the critical bolt. Why critical bolt? Here theta is minimum but R is maximum. Okay, very important examination question. Now next point we can write under this, R has more significant, more influence than theta, more influence than theta on PR. R has more influence than theta on PR. Okay, so these are the important things that you have to keep in your mind for eccentric bolted connection. Now in the same thing I'm going to do in the weld. So what is there in the welded connection that we are going to see? It's very simple. Everything is same except instead of this bolt, we are going to use the weld. Okay. Now you see the same diagram that I'm going to draw to understand the concept of weld. Okay. Now one more point that I wanted to say. Okay. Here for design this PR, the resultant force is less than or is equal to design strength of bolt. So PR less than or equal to what is the design strength of bolt? Ultimate strength of bolt divided by 1.25 root of 3. So this also a condition that shall be satisfied for a design. Okay. Now for a belted connection, this is your connection bolt to groove. Here not a bolt to groove exactly, it's a weld to groove. Okay. Okay. So somewhere here we are having a load P. Here the weld is made up of, or weld is done like that. So this is the weld. Okay, this is the weld. Okay, so this is the weld. Now see, from here to here we can take it as this is the breadth B. This length you can take it as height, depth of the weld. This also B. Okay, now see, center of this weld. Okay, centroid of the weld is somewhere here. You can take it as the centroid of the weld group is somewhere here. Okay, so this is the centroid of the weld. Your centroid of the weld is somewhere here, but the centroid of the load passes somewhere here. Right. Now the distance between these two, we can call it as eccentricity. Now we can, because of this eccentricity, you can convert this load about its centroid for our analysis. Therefore, if you convert this about this centroid, so there are two forces are acting. One is P, another one is a twisting moment, P into E. Another one is a twisting moment, that is P into E. Now this is also in plane loading. This is the bolt group and this is the load. Both are lies on the same plane, right? Okay. Now you have to take 4 points. This is the point number one. This is the point number two. This is the point number four. Sorry, point number three. Point number three. So this is the point number four. You know, from here to here, this is the line which is connected with the extreme point with the centroid. Okay. Now here also the weld is subjected to. We can write here bolt is subjected to here. Weld is subjected to two forces. One, one shear stress due to direct load. Okay, that's a direct load is P, which is equal to PD. Here also I have to write like that only. Direct load P, which is equal to PD. Here is a twisting, that is P into E. That is P into E, that is PT. The second one is shear stress due to twisting. Shear stress due to twisting, that is P into E, which is equal to PT. So this is the thing. Okay, so that is these are the important points. Now we are going to write in the similar manner here also. Okay, so that is PD. Here PD we can calculate a total force divided by number of bolt, but here the total force divided by area of weld. Area of weld. So which is equal to P divided by what is area of weld? L effective into throat thickness. Okay, so that's the thing. Next one is PT. PT is equal to P into E divided by the summation of R square into Ri. Okay, but here instead of the summation of R square, you have to take IP. Okay, what is IP? IP is equal to polar moment of inertia, which is Ixx plus Iyy. You know, this is your section. So this is our section. Okay. Section. This is the weld. The weld in the form of channel, right? The weld in the form of channel, and here the centroid is this one. This is the centroid. So this is the centroid. Okay. Now, this axis x. This is y. We have to calculate ixx and iyy, and this PD will be at about this point 1 is in the upward manner. This is the PD, and PT will be at PT will be at something like that. In the similar manner of bolted connection, this is the PT by an angle theta. Okay, in the similar manner, point number 2, this is your PD. Okay, and this is your PT. And point number 3, this is your PD, and this is your PT, and this angle is theta. Similarly, this point, this is your PD, this is your PT. So this is angle theta. Okay. Now, now here this is also a theta. We understood, right? Okay. Now everything is fine. The resultant stress where it is acting. The resultant stress is calculated similar to this. Somewhere here it will go flow like that. This is a PR. Similarly here also the resultant stress will be act. That is PR. Similarly for this junction. Okay. Now PR is written as root of PD square plus PT square plus 2PD PT cos theta. So this is your resultant stress PR. Now, what is the condition? Condition for PR max. Condition for PR max, that is R, similar to the previous one, R maximum, R maximum and theta minimum. And theta minimum. Then for design, the PR shall be less than or is equal to design strength of weld. What is this FW? Design strength of weld. Then only it is safe. What is the design strength of weld? We can write this FW is equal to PR less than or is equal to FU divided by root of 3 into 1.25. Okay. So this is the condition. Okay. Similar to that also, similar to eccentric loader connection, we have done the weld also. This also in plane loading, this also in plane loading. I hope both are similar in nature, right? Here one thing you have to keep in your mind, this bolt in plane loading, the bolts are subjected to shear stress only due to direct load, due to twisting moment. Be careful. Okay. Now in this eccentric load, okay, in this eccentric load of bolted connection, there are special cases. So there are special cases. The case number one. Special cases. Case number one. Suppose there was a bolt group. There was a bolt group. For example, there are four bolt, and it is subjected to a load P here. It is subjected to load P here. Okay, this is the centroid of the bolt group. Now, from here to here, the distance we can take E, and the same distance from here also we can take E, eccentricity E. Now, if you resolve this force about its centroid, I can resolve this about its centroid. Summation of these two forces, P plus P, is equal to 2P. And about this centroid point, moment is equal to, this is P into E in the anti-clockwise direction. This is P into E in the clockwise direction. Therefore, net force due to moment is 0. Therefore, now each and every bolt is subjected to only direct, that is shear stress due to only direct load. So shear stress due to direct load, that is 2P. So therefore PD we can write 2P divided by number of bolt. 2P divided by number of bolt. Understood? Now PT due to shear stress due to twisting is equal to 0. Why 0? Since there is no movement. These two are getting uh, neutralized. PE getting 0. Right? Therefore, what is a PR? PR is equal to square root of PD square plus PT square 0 plus 2P PD PT. This is also 0. So answer for this is PD. So PR is equal to PD. The special case is case number 2. So I can mark here. I can write it here. Case 2. The case 2. Suppose you are having a bolt group. So here there is a load P. Here there was a load P. 1 bolt, 2 bolt, 3 bolt, 4 bolt. So this is the centroid of the bolt group. Centroid of the bolt group. If you resolve these two forces about centroid, then one force is downward P, another force is upward P. Therefore, here the direct force getting 0. But this force create an eccentricity of E about centroid. This force also create an eccentricity of E about its centroid. Now, this is create a clockwise P into E about centroid. This also create a clockwise P into E. Both are clockwise. Now, here only PT is subjecting for each and every bolt. What is a PT? Is shear stress due to twisting moment. What is a twisting moment? PE plus PE, which is equal to 2PE. Okay. Therefore, PT we can write what? 2PE M divided by summation of R square into Ri. Okay, for each and every bolt. Okay. Therefore, here PR is equal to square root of PD square. PD square is what? 0, right? 0 square plus PT square plus 0 square. So which is equal to PT. PR is equal to PT. So these two are the special cases. Okay. So with that, we having seen in-plane loading cases. Now we are move on the outplane loading cases. Okay. The outplane loading cases, that is this. Okay, in the eccentric loaded connection, case B that we are going to see now. Outplane of loading. Case B, outplane of loading. So these two are both are same. Okay, outplane of loading, meaning here bolt group, bolt group and line of action of load are not lies on the same plane. That is a bolt group and line of action of the load are not lies on the same plane. Okay, the similar manner here. What is the meaning of plane load? That is a weld group and line of action of load are not lies same on the same plane. That is a thing. Now we are going to write first outplane loading case. Okay, in the sense bolt group we are going to do. Okay, see, there was a case. Okay, you can draw. So this is the bracket. This is the column, for example. This column is connected to this one. Okay, another bracket, and these two are connected by a bolt. Okay, and if you see in the front view, okay, you know, this is the bolt group. Okay, so the bolt group is on this plane. That means this plane you are having a bolt group, but your load is somewhere here. This is the load P. Now the centroid of between those two load and the centroid of the bolt group is E. Now, because of this, think about it, this is like a cantilever beam. If you draw a free body diagram, this end is fixed here, and this is the bracket. This is the load P is acting. Because of this load, how it will bend? It will bend something like that. So, because of this load, now this bolt is subjected to, there are two stresses. One is a direct stress, another one is a bending moment. Okay, but in the last case, in plane loading, there is a twisting moment, but in outplane loading there is a bending moment. That is a difference. Okay, now if you look these things in a front view, then you can able to see, so you can able to see this. So that is this one. Okay, There was a load P. This load is acting, and there are 4 bolt. One. That means if you look in the front side, okay, from this side, if you look this in this front side, then you can able to see such kind of thing. 1, 2, 3, 4, and this side also 1, 2, 3, 4. Okay. Now this is the diagram. Okay, in the similar manner, we can draw the diagram for outplane of the welded connection. Okay, so outplane load for a welded connection is this one. That is this. Okay, the diagram is more or less same as the bolted connection. Okay, nothing is different. And okay, and here the bracket is connected with this. So this is the bracket. Okay, this is the bracket. Now the weld is happened like that. So here this is the weld. Weld is made something like that. And for this side also, this is the weld which was made it. Okay, now this is the load which is acting P, and this is the centroid of the weld. Distance between these two, which is equal to eccentricity E. you know if you see this in the front view or in the side view, in the side view, then you can able to see such kind of diagram similar to this only, right? Here bolt, here weld, that is a difference. Now you can able to see such kind of diagram. Okay, and this is subjected to a force P, and here the weld is, if you look, then you can able to see the weld is on the outer face. Weld is on the outer face. So this is all about the diagram. Okay, now see, here we can write important point. The important point is this one. The welds are here subjected to, in this case first one, bolts are subjected to bolts are subjected to one, direct load. Second one is bending moment, but they are twisting moment, right? Therefore here bending moment. Similarly, here welds are subjected to one, direct load. Second one bending moment. Second one bending moment. Here the direct load. See, for this case, The direct load for welding. Okay, so this will be, if you resolve this force, then this is the direct load P, and this is the bending moment P into E, and the resistance will be happen above the neutral axis. This is the PD, and because of the bending stress here, the PT will be active. This is the bending, that is a tension stress due to bending moment. So this is the resultant force. This is the PR, resultant force. Because of this bending, top above the neutral axis, somewhere here you are having a neutral axis, neutral axis. So above the neutral axis, the bolts are subject to the tension and the direct shear. Below the neutral axis, the bolts are subjected to that is compressive force. Okay, that is PC, and the direct force, that is a PD. In the similar manner, here also, due to this, we can analyze this into direct load about centroid as well as bending moment P into E. And here also there was a centroid, sorry, neutral axis. This is the neutral axis. This also neutral axis. Above the neutral axis, it is subjected to direct load PD, and this point is subjected to tension force due to bending moment, and this is the PR due to direct force. Sorry, due to these two. Similarly, at this point, we can write it. This is the P and D, but at this point below the neutral axis, it is subjected to compressive force PC. Okay, compressive force PC. Now we can write here, due to direct load. Due to direct load, the corresponding stress is the shear stress. That is PD. Due to bending moment, the stress is tension or compression. Here also, due to direct load, the corresponding stress is shear stress. That is PD. Due to bending moment, the corresponding stress is tension or compression. In the tension, we can write PT. Compression, we can write PC. And here also tension PT, compression PC. So that is the thing. Okay. Now we are going to do the analysis. I hope you understood this one. Okay. Now see, in the bolted connection, first of all, we can see the bolted connection. What is the concept? Okay. So in the bolted connection, we can see, we can write the point due to direct load, due to direct load P, all bolts are subjected to shearing and bearing. Shearing, bearing. Okay, then due to next point, due to bending moment, due to bending moment, bolts above neutral axis are subjected to shearing, shearing and bearing. Okay, subjected to not subjected to tension or compression, subjected to tension, whereas whereas bolts below neutral axis are useless resisting compression. Useless for resisting compression. Okay. Compressive stresses compressive stresses are are resisted by flange of I section and portion of the bracket below the neutral axis pressing against each other. Pressing against each other. Now we can write next point. Bolt, therefore bolt above neutral axis subjected to above neutral is subjected to shearing, bearing, and tension. Shearing, bearing due to direct load, tension due to bending moment. Okay, whereas bolts below neutral axis are subjected to tension and shearing. Subjected to tension and shearing. Okay, subjected to shearing and bearing. Shearing due to direct load and shearing and bearing due to only direct load. Okay, bearing only. We are not taking into account the bending stress. Okay, now we can write what is PD and what is PT. The PD which was calculated by a relation. So PD is equal to shearing and bearing due to direct load, which is calculated as total force divided by number of bolt. That is a PD. The second one is TB is the tension due to bending moment. Due to bending moment. So which is equal to M dash Yn divided by Ya. Okay, this is the bending moment formula, right? Tension. By the bending equation, you can take it as M into Yn divided by summation of Yn. Okay, this Ya square. Yeah, only Ya, not Ya square. Here M dash is equal to total moment divided by 2. This M dash equal to P into E divided by 2. Okay. Now Yn distance measured from neutral axis to extreme fiber, extreme bolt. extreme bolt, that is a YA. Okay, YA is the distance of bolt which is measured from the same thing. Okay, YI, YN, both are same only. Okay, so this is the thing. Now, here the important point that you have to keep in your mind, that is for safety, considering the safety, considering the safety, is for safety, for safety, we can write like that. Since above neutral axis, since bolts above neutral axis are subjected to are subjected to tension and shearing. Okay, above subject to tension and shearing, the interaction equation, the interaction equation to be used to be used to prevent the failure of bolt, okay, is given by is given by is given by PT calculator the whole square. Okay, that is this PT divided by actual PT. PTC I am taking. So this is PT. Let us take PT. The whole square plus PD divided by PDC the whole square less than or is equal to 1. Less than or is equal to 1.0. Here what is a PT? PT is equal to calculator tensile force. Sorry, yeah, calculator tensile force. PTC, which is equal to capacity of bolt, capacity of bolt, that is a tensile capacity of bolt, tensile capacity of bolt. Then PD, calculator shear stress due to direct load. PDC is equal to shear stress, calculate shear stress of bolt, tensile force of bolt. So this is shear stress capacity of bolt. So shear stress capacity of bolt. So this is the point that you have to keep in your mind. Okay, now we are moving to this one. Case B, the outplane loading in the welded connection. Okay, so in that shear stress we have done. Tension or compression due to bending also we have written. Right now, here also we can write so some of the important point. Okay, the same as uh, the bolted connection. Okay, see, due to direct load, all bolts here, but here the welds are subject to shearing and bearing. The same thing. Okay, so what I can do, let me take, this is the point number, point A. This point is A. Okay, see that point. I can write now, due to direct load, P, the vertical shear stress, that is PD. So this one, PD. Okay, vertical shear stress PD is developed at A. Vertical stress PD developed at A. At A. Okay, this PD is uniform. This PD is uniform throughout the length. Throughout the length. Throughout the length of weld. Next one. Due to bending moment, bending stresses, due to bending moment, bending stresses, okay, bending stresses. Here is tensile stress. Bending tensile stresses is developed same as this one. Okay, bending tensile stresses develop in the belt, in the belt at a point, at a point A. This bending stress, this bending stress, this bending tensile stress will act as horizontal. See, it acts as a horizontal, right? Horizontal shear stress. Shear stress, that is, we can write PT, right? This is the PT at A. Okay. Therefore, the resultant stress at A, resultant stress at A at that point is equal to square root of PD square plus PT square. Yes or no? There are two forces are acting at a right angle, then the PR is equal to these two square. Okay. Then for design, this is PR, okay, resultant stress PR. For design, the PR less than or is equal to, okay, FU, that is a permissible stress, permissible shear stress, FU root of 3 into 1.25. Okay, so this is the point. Okay, now we can write the calculation. Okay, calculation of this. What is a PD? PD, which is calculated by, what is a PD? Total force. See, this force P divided by the total area. So P divided by area of the weld. Area of weld. So P divided by what is the area of weld? Area of weld is equal to 2 times the throat thickness into depth. Here the depth in the sense height of the, or we can take this is the depth of the section. So this is the thing. Then what is a PT? PT is equal to similar manner P into E, M divided by IXX, moment of inertia about XX axis into Y. Okay, so this is the neutral axis. So the stress PT above the neutral axis at this point, PT is equal to above the neutral axis. So you have to calculate XX. In the bending moment, you have to calculate XX. So this is a point Y. Okay, so this is Y. IXX into Y. Okay, now what is a IXX? IXX we can write for that case. IXX equal to, we can write what? B into DQ divided by 12. B means what? 2 times the throat thickness, breadth of the section. And Y is what? Is a distance from neutral axis to extreme fiber, which is equal to D by 2. Okay, so this is all about PD and PT. So I hope you got it. Okay, so this is the thing all about the eccentric loader welder connection. Okay, yes. So with that, we having seen the eccentric loaded bolted connection, in plane, out plane, eccentric loaded welted connection, in plane, out plane. Okay, so you have to go through this. This is enough. Okay, in the out plane loading, eccentric loaded connection above the neutral axis subject to the tensile stress due to bending moment and shear stress due to direct load. Here also tensile stress due to bending moment, direct stress due to direct load. So that is a, in nutshell we can say. In nutshell we can say the outplane of loading above the neutral axis, the bolts are subjected to tensile stress due to bending moment, direct stress due to direct load. In the belt also, tensile stress due to bending moment and direct stress due to direct load. Okay, so that's the thing, you just go through it so that you will get everything. Okay, so this is all about the problem. So we having we having seen everything. Okay, now we can go for the next topic. The next topic we'll see the tensile member. Okay, so that's the thing. Here there was a small mistake, that is this is yi square. That is a mistake. So the rest of the thing is fine. Okay, only that is small mistake. Okay, thank you.